Now that we've looked at significance testing for large samples, or if the population standard deviation is known, what about those other cases? What about when my standard deviation is unknown, and I'm dealing with a small sample? Well, if we remember before, this is where we did our t-interval. So similarly, we're going to make our t-test. Our test statistic, instead of being a z-value, is going to be a t-value. It's going to use a lot of the same information, except we're going to use the standard deviation of the sample, lowercase s, instead of the standard deviation of the population, because that's an unknown value. The difference here is when we go look for our critical values, we need to keep in mind our degrees of freedom, which is our n minus 1. This is still called my test statistic. That hasn't changed. I'm still looking for my critical values. That hasn't changed at all. The only difference is I'm going to have to use my chart. I'm going to have to use my degrees of freedom. I'm still going to look at my one or two-sided test. I'm still going to have rejection regions. The difference is, instead of using inverse norm in the calculator to get your two critical values, or your one critical value if it's a one-sided, you're actually going to have to go use your chart. You have to look up the percentage that you're looking at, percentage of significance, and you have to focus on your degrees of freedom. Keep this in mind. If this is a 5% significance, that means you have 2.5% on both sides. This would be similar to a 95% confidence interval.